right, so since we've talked about division, let's do that. If we divide numbers that are complex numbers, then what we want to end up with is a number which is a complex number in the form of a plus bi. So let's take an example. Suppose we take 5 plus 2i and we divide that by 7 minus 4i. Now, we want to write this as a number a plus bi, which is a complex number in standard form. The I think it's the square root of a negative 1. When we had square roots in a binomial before, what we did was to rationalize the denominator. So in a way, that's what we're going to be doing. We'll take the 5 plus 2i, the denominator by the conjugate of the denominator, and the numerator by that number as well. Once again, we want to multiply by a number over itself, which is 1, because we don't want to change anything that we started with. All right, but just as we previously mentioned, when we multiply the denominator by its conjugate, we have the factors of the difference of 2 squared. So for the denominator, we will end up with the first number squared minus the second number squared. Okay, let's continue working with that denominator. We have the square of 7, which is 49, minus 16i squared. Well, that ends up being simply as 49 plus 16. Right? And so by adding those two numbers, the denominator then becomes purely a real number. And so that's 6 and 9 is 5, carry 1, 2 and 4 is 6. We end up with a plain 65. This will help us in writing the number then in standard form. But now let's look and see what we have in the numerator. Well, for the numerator, we have the 5 plus 2i, which is multiplied by 7 plus 4i numbers. So let's go ahead and do that. And if you remember, we'll multiply 5 times 7, that's 35. 2i times 7, that's a plus 14i. 5 times 4i, which is a plus 20i. And then finally, 2i times 4i, which is a plus 8i squared. The I squared is once again minus 1, so this is going to be a 35 minus 8, and the imaginary part will be 14i plus 20i, which will give us a 34i. Finally, we end up with 35 minus 8 plus 34i divided by 65. Well, as you can see, we can, since we have no 65ths plus 30, then to have the denominator become a real number, the number 65. Then we can separate that and write it as an a plus bi number, which is a complex number. Okay. Now suppose that the number that we were dividing by happened to be perhaps a little bit simpler than this. So for 5 minus 6i, and we were dividing this by 3i. When we want to eliminate the i's in the denominator. In this case, if you have simply an imaginary number in the denominator, you could multiply by the conjugate of this, which is minus 3i. So when we have just simply an imaginary number, all we can need to do really is to multiply by I over I. But you can also think of multiplying by the conjugate, and that would also, since the denominator becomes 3i squared, and we end up with a plain negative 3 in the denominator. For the I squared is negative 1, so this term minus 6i squared becomes a plus 6, and then the 5i remains as it is. But now we can separate this as 6 over a negative 3 plus 5 over a negative 3i. We can, of course, simplify each of the terms within the term. 6 divided by a negative 3 is a negative 2, and then we have a minus 5/3 I. So once again, this number is in the form of a plus bi. Okay. All right.